Exercise 506 is about curve sketching. Now the things we have to consider here are any stationary points, any points of inflection, any x or y intercepts, the symmetry of the curve, and any asymptotes or discontinuities. So you've got to think about the domain and range. Now I've put these in the order that the textbook puts them in, but to be honest, when I do curves with asymptotes or discontinuities, I always like to think about the domain and range right from the very start of any problem that I do. For any function really, that's the case. So example 1 is to sketch f of x equals x cubed minus 3x squared. So the first thing we want to do is think in our head, what does this look like? Now as a cubic function, a positive cubic function, it's going to have that general shape. It is possible it could be like that, but that's the general shape. And it's good to know that in your head. So domain and range are negative infinity to positive infinity for both. Okay, so let's take the derivatives. So the first derivative is 3x squared minus 6x. I'm just going to factorize that as well, 3x x minus 2. When you take the second derivative, just go back to that first line. So derivative of that is 6x minus 6. I'll factorize that one as well. It's often easier if it's in a factorized form. Okay, so to find stationary points, we want to look at where the first derivative is equal to 0. So where does 3x x minus 2 equal 0? Well, we know it equals 0 when 3x equals 0, in other words x equals 0, or x equals 2, 2 minus 2. We need to find the y coordinates of those. So when x equals 0, y is 0 cubed minus 0, so it'd be 0. When x equals 2, we'll just substitute that in, y would be equal to 2 cubed minus 3 times 2 squared. So 2 cubed is 8, 3 fours are 12, so negative 4 for that one. Okay, we need to determine the nature of those stationary points. The easiest way to do that is generally to put them into the second derivative. So the second derivative at 0 is going to be 6 times 0 minus 6, which is negative. So think of a sad parabola, that is a maximum turning point. The second derivative at 2 equals 6 times 2 minus 6, so 12 minus 6, so that's positive. So that's like a happy parabola, so that is a minimum. So we have a maximum at 0, 0, and we have a minimum at 2, negative 4. Okay, we need to look for any points of inflection, so that's when the second derivative equals 0 to begin with. Don't forget we do need to check that concavity changes to ensure it is a point of inflection. So we want to know where does 6x minus 1, notice I'm using the factorized form, equals 0, and that's when x equals 1, which would be y equals 1 cubed minus 3. Don't forget to find your y coordinate, that's really important. If we're in class, I'd be purposely leaving this off and reminding you constantly to remind me to find the y coordinate. So that's 1 minus 3, that's negative 2. So let's just check if concavity changes. So when x equals 1 is where we got 0. So something just to the left of 1, so let's go 0.9. And something just to the right of 1, so let's go 1.1. So if we put 0.9 into our second derivative, 0.9 minus 1 is negative, so 6 times a negative, that's negative. If we put 1.1 in, 1.1 minus 1 is positive, positive times positive is positive, so concavity has changed, so therefore there is a point of inflection at 1, negative 2. Okay, intercepts. So when x equals 0, y equals 0 minus 0. So there's an intercept at 0, 0. We already found that. That was one of our stationary points. And when y equals 0, we've got x cubed minus 3x squared equals 0. Factorize it. X minus 3 equals 0. So we've got one at x equals 0, which is that one we found there, or x equals 3. Okay, so we need to put all of that information onto our graph. So I'm going to start by marking the intercepts. So we've got one at 0 and we've got one at 3. The next thing I'm going to do is mark the stationary points that we found. So we found a maximum here, that's a maximum that's already marked, and a minimum at 2, -4. So 2, -4 would be down here, and that's a minimum. Let's mark the point of inflection. So that was at 1, -2. So that's right there. And there is a lot of symmetry here. It happens quite a lot. So let's just go ahead and sketch that curve. So we know that it goes from the point of inflection. It's going to be concave up over here. We found that the second derivative was positive in this area. So it's going to look like that. And then it's going to go up to the maximum. It's going to be concave down. It's going to come back down. And that's our curve. That is the curve f of x equals x cubed minus 3x squared. We have made it clear by putting all these numbers on here where each of those things are. You can either put them on the axes if it's really clear, or you can write them next to each one like that.